Hello, can you hear me all? Awesome. Well, first of all, thanks for having me over here. It's really a great pleasure. And it's my first time in Croatia. I had the chance to go around a bit yesterday, and I love your city. So today we're talking about machine learning on Android. A bit about myself. I am an Android developer at Pixplicity. It's an agency in the Netherlands. And I'm also a Google developer expert on voice. And as already mentioned, I love traveling a lot, especially for conferences and meeting the developer communities. If you want to follow along, or if you want to get to grab the slides, this is the link. Hopefully the QR works as well. I'll show the link later on as well. So let's start with the actual definition, like what is machine learning? Machine learning is a subfield of artificial intelligence, and it allows a machine to automatically learn from past data without programming explicitly. And of course, the next question is, so what is artificial intelligence? Artificial intelligence is broadly defined as the capability of a machine to imitate intelligent human behavior. Artificial intelligence systems are used to perform complex tasks in a way that is similar on how humans solve problems. And I know that it's difficult for you to maybe grasp it. Those terms, as we will see, sometimes they kind of used in the same way. So AI is basically any technique that enables computers to mimic human behavior. And this means a machine that can recognize, for instance, text, that it's a natural language for us. It can recognize a scene. What else? Perform an action in a physical world, like all of this. And it also includes machine learning. So machine learning is a subset of AI, and it includes techniques that enable machines to improve and improve at tasks with experience without a person to program them explicitly on that. And then we have deep learning, which is also a subset of machine learning, and it's based on neural networks. If we want to simplify it, we can roughly do it as it is. So AI is programs. Machine learning is the algorithms, and then we also have deep learning, which are the models. And the models are just a fancy word for actual algorithms as well, but very specific algorithms. There are algorithms that use neural network, which is like a human brain structure. So if we want to, all deep learning is machine learning. All machine learning is AI, but it doesn't go the other way around. So not all AI is actually machine learning. So let's see some ML, like machine learning applications that we can have. Machine learning can be descriptive. A system of machine learning can be descriptive, meaning that it's using, the system uses the data to predict, to explain what has already happened. It can be predictive, which means that it will use that data to, this is a bit confusing, I'm sorry. Okay, predictive, which will use the data to predict what is going to happen. And then we also have prescriptive, which means that it will use that data for suggestions about what should happen or what should we do. So as you can imagine, there are a ton of applications of machine learning and AI in general that we can actually do. Like it can predict, it can tell us what to do, and it can tell us what we had already, what already happened and why. And some of the machine learning applications include virtual assistants like the Google Assistant or Siri and Alexa. It has image recognition, like the email filtering with the spamming. It can be the text and the speech recognition. It has limitless capabilities. So those examples, like you may say that like this is everything that comes to mind when you say smart or like a human behavior from a machine. Is there artificial intelligence without machine learning? Well, yes, of course. Companies nowadays use it to like deploy artificial intelligence programs, and they use machine learning and artificial intelligence like the same word, basically, which can get the users and the developers quite confused. But let's see an example of artificial intelligence that doesn't use machine learning. And those are, for instance, chatbots. Chatbots can use machine learning, but they can also not use machine learning. Like the old chatbots, for instance, they were not using any machine learning. It was just rule-based. In 1985, there was a term for that. It's like the good, old-fashioned artificial intelligence, which is basically not using anything smart as we currently know it, but just use rule-based or other algorithms that do mimic some human behavior. Like it makes it a little smarter. It gives a reply, for instance. It can understand you, but it's not as smart as machine learning systems. Let's see an example over here, the chatbot example. So chatbots have been around since the 1960s. It's not something like that came out yesterday. I am really sorry for the delay. This is kind of confusing. This is a little slower, so sometimes I don't know which is the slide. Anyway, so for any machine learning and for any artificial intelligence system, you need to provide some data sets. And the data sets in the chatbot example, it would be training phrases. In this example, like what it's like outside or what's the weather. And of course, you wouldn't just provide 2 of them. You would provide a ton of them, like different ways that the user would ask that. Now, if the user says, what's the weather like today, then the machine learning will use the natural language processing and actually understands what's, like, it will give a reply to the user. If we don't use machine learning, though, then it's not going to give an example, because a response, because then it can't match the pattern exactly as it is. So how does machine learning work? Well, as brain, like the human brain gains the knowledge, it's the same thing with the machines. They gain the knowledge exactly the same way. They get the data, they get some feedback, then they improve, and then they get better and better. That data can be numbers, photos, text, stock prices, anything that you want, like sales, it can be whatever. So the data is gathered, it's prepared, because we can't just feed to an algorithm whatever input we want. So it's prepared, and then that information will be used for training through the algorithms. From there, programmers choose a machine learning model, or otherwise an algorithm, the right algorithm, and then they will find like patterns that work with that. Sometimes they will need to go back, like the human programmer will need to go back and improve on that model, sometimes by just scrapping the data and making sure that there is no noise in there. Some other times by just modifying some of the parameters. It really depends on like the input that we have. Part of the training data is going to be for the evaluation. So which tests, like we need to test how accurate our current model is. So we have part of our input data, we will fit it there, see how accurate it is, go back to the human programmer, modify anything possible, and then continue to do that. And the result is the model that can be used for classifying or for anything else, depending on our use case. So there are two categories for machine learning. The first category is the supervised, and the second one is the unsupervised. And each of them have two different use cases. So for the supervised, we have the classification and the regression. And for the unsupervised, we have the clustering and the association. So supervised machine learning models are trained with labeled data sets. As we can see over here, it will get a data set and it will try to cluster it, to classify it to wherever it is. So in this example, it's going to be cats or no cats, because cats are just labeled. As the name suggests, supervised ML involves actually someone to go to the model and say, like, yes, this is a cat, this is not a cat. So we provide feedback. And this person will also be the one that will evaluate the results that the model is giving us. A classification example would be predicting the probability of a rainfall, getting the previous data for the weather for that specific, for those specific dates, and the previous data that we have. And for the regression example would be stocks, because regression uses real values, while the classification is just sorting things into different categories. Another example for classification would be the spam, by the way. If it's a spam or if it's not a spam. That's what we need with classification. So then we also have the unaided machine learning. And the unaided machine learning is basically looking for hidden patterns. It's patterns that humans cannot easily find or identify, and this is why we are using it. As you can imagine, the unaided machine learning is quite difficult to do. So we normally don't do it. Like, whenever possible, we're using the aided one. And for this one, we also have two different categories. We have the clustering and we have the anomaly detection. Clustering is for identifying similarities within a group. And this would be, for instance, putting products together, or like articles, like clustering articles together in different subcategories. And the anomaly detection is probably, it's mostly used for, well, problem detection. A great example for the anomaly detection and where it was used, it was for cancer research, and for finding cancer cells in scans. Because the human eye is not trained in finding patterns like this, but algorithms really did an amazing job on this one. So why is machine learning important? Well, I think that like everyone can understand the importance of it, but first of all, it's fast. It can perform tasks that it would take a human a lot of time and just a fraction of this time. They are very accurate. They are better than what we can do in a lot of those different tasks. And finally, it can detect patterns that humans can ignore, like the cancer research that I told you before. So we're here for the Android part and the ML on Android. So let's see. First of all, we have the ML kit. Who of here has heard it? Okay, a few hands. And who has used it? Okay, fewer hands. So MLKit is created by Google, and it brings Google machine learning into Android in some specific areas, as we're going to see. MLKit is divided in two categories. The first is the vision APIs, and the other one is the natural language APIs. And the vision APIs includes text recognition, digital ink recognition, object detection, face detection, which is not the face detection like, hey, this is John and this is Erica. It's basically just finding where your eyes and your mouth are, the expression, if you're happy, if you're angry, stuff like this. And then we have the image labeling and the barcode scanning, the pose detection, and finally the selfie segmentation, which is basically just recognizing where the face is and where the background starts. And for the natural language, we have the language identification, we have on-device translation, smart reply, and entity extraction. So why MLKit? Well, first of all, it's very easy to use. I have some examples over here, and we're going to see that it's literally 10, maybe 15 lines of code. So it's very easy for you to implement it into your projects. And it doesn't take anything from the structure. Then it's on device, which also means that it's real time, so it's very fast. And if you have any sensitive data, it doesn't have to go online anywhere. It's just on your device. And of course, for that reason, it works offline as well. But sometimes we have like applications that don't really fall into those categories. Like, can we do something about that? Well, yes. We have the custom models using the MLKit. So you can customize those models. And there are also some pre-trained models. You can put in your input there, your data set, and then basically it trains the already model with your data set. A great example for that is we already saw there is an image labeling API in the MLKit. But that image labeling, it has 400 different image labels. It will say that this is a chair, or this is like a dog, this is a cat, but it won't tell you which dog breed it actually is. So if you want to specifically say like what type of like the dog that is, or what family that flower is, then you need a custom data set for that. And then we have AutoML. AutoML is used for image labeling and object detection. And it's a cloud API. It has a graphic user interface, so you basically go there, you put your data there, you customize that algorithm, which is different from what the MLKit is doing. And then you can use that model inside your Android application. It's easy to use because it has a graphic interface. It provides high-quality custom models because it gets pre-trained models, and it basically trains them again on top of your data set. It does need some limited ML expertise. So you do need to know a few stuff about machine learning because you have to put the parameters right in order to get a good machine learning model. It's very fast when it's training because it already grabs a custom model, an existing model. And it has all the benefits of the MLKit. So it works offline, it works on device, and it's real time. And finally, we have the TensorFlow Lite. And TensorFlow Lite is basically used for all the rest of the applications that we can't use any of the pre-trained models. TensorFlow Lite is basically TensorFlow. So there is no easy way. It's machine learning unless you put a lot of effort and a lot of knowledge and a lot of time in there. There is no way that you will come up with a good model. So basically, you do need machine learning expertise. Then instead of just getting a TensorFlow model, you get a TensorFlow Lite model, which will then go inside your application, your ML application. Most of the times, it works really well. In some cases, for instance, the project that I was working on, it was on audio, and it had to grab some input from the microphone and then feed it into the model. That was a bit more difficult than we anticipated. So let's see like the pre-trained TensorFlow Lite models, because as we had with the AutoML, We also have a few that are from the TensorFlow Lite. So again, you do need machine learning expertise to get them right, but it's not like starting from scratch. It's a little better. So these are the pre-trained machine learning, like TensorFlow Lite models that exist. If that covers you, then you start from here. If that doesn't cover you, you start from scratch. Let's put that into a spectrum so you can understand better the differences between all these three. So we have on the one side, the build your own machine learning skills, and on the other side, we have the pre-trained or pre-packaged machine learning. And first of all, we have TensorFlow. Well, TensorFlow is just completely from scratch, or the pre-trained models. You do need some machine learning expertise. In the middle, we have the cloud machine learning. And then at the end, we have the machine learning APIs. And of course, we're talking about mobile. So this translates into TensorFlow Lite, into AutoML, and in the ML kit. The further away you get from this side, then the less friendly it becomes for you. So enough with the theoretic part. We said that ML kit is very easy to implement, so let's actually see how easy it is. And we are first going to start with the image labeling, the first example that we're going to see. Image labeling has, as we said before, about 400 labels. It can recognize objects or people and some other stuff. Activities as well. So here, there are two ways to implement it. The first one is the unbundled, which means that it's dynamically downloaded when the user starts the application. The second one is bundled. We basically ship the APK with the model inside there as well. The app size, well, there is a big of difference. So for the first one, it's about 700 kilobytes because we just download it afterwards. The third one, it's 7.3 megabytes because the models are quite big. And finally, for the initialization time, well, it needs to be downloaded. So the first one is a little slower. The other one is available immediately. If your application doesn't heavily depend on that machine learning model, then I think that there is no really a reason why to go for the bundled one and not the unbundled. So let's see the steps. Well, the first step, as with everything in Android, is basically the dependencies. And for the dependencies, we have one dependency, the image labeling. If we have, if we use the unbundled one, or we have a couple of more dependencies to make sure that Firebase actually works if we have the bundled one to download the model. Then we have to prepare the input image. As we said, like, we can't put any input that we want. We need some specific data on that. So depending on how we get our image, we need to prepare it appropriately. And for that, we have 4 ways to do that. The first one is using the media.image, which is basically camera. If you're using camera X, for instance, or camera 2, it's very easy to do. We will see how. My example is one of them. Then we have using the file URI. It's basically when you get the gallery, the photo from the gallery. And for the other 2, it's like lower level APIs just to cover all of the use cases. So for this example, the first one, we're going to see how it works with the camera. So first, we need to have an analyzer. And we create a new class for our analyzer object. And there, we need to override the analyze method. The image proxy that you see over here, it will provide us with all the data that we actually want. Because we're using the camera X, then we don't really have to do anything with the rotation or any further modifications. We just use it as it is. And we just need to create like a media image using the rotation information over there and the image proxy parameter that we're getting from the analyze method. It will calculate, of course, the rotations and the translations and everything for us. So then we can pass our image to the ML kit using our labeler, image labeling.get client. We're going to use the default options because we're not doing anything fancy with that. And finally, we can just get the information about the labeled objects. And to get it, we just get the process image method. We pass our image that we've already prepared over there. And we have two listeners, like the success and the on-failure. For this image, that would be the results that they will come back to us. So it kind of recognizes that it has chairs, it has a room, it has medals, it has desks. And here we also can see on the right side the confidence score. The confidence score is how sure the machine learning model is that this is actually a chair. So we can say that it's 89% confident that this is indeed a chair. But it's only like 54% sure about the pattern because it's in the background. So let's see now how it actually works with custom machine learning models. And we're still in the ML kit. Let's say that we want to identify landscapes, like around the world, very famous buildings or parks or whatever. Well, we can't do that using the image labeler that we saw before, because it recognizes chairs and activities and stuff like this, but it doesn't really recognize exactly that, oh, this is the Tower of Pisa. It may recognize a tower, but that's about it. There is a TensorFlow hub. It's a website. And it has a bunch of machine learning pre-trained models that you can just download over there and import into your application. And they're already trained with a lot of data sets, so you don't have to customize anything. You just grab them as they are. And here we see that we managed to find a landmark one. And it has like from Africa, from Asia, like it really comes down to which continent you want to use your machine learning model. And you can see also on the right side that it has some useful links for you, so that if you don't know how to implement it, you can just go there. It will take you to the documentation or some tutorials and find out which API you need to use. So first of all, again, it's dependencies. The dependencies we're going to use for the bundled one, so it's just one dependency. Again, if we wanted the unbundled one, we should also have Firebase in there and Google Play services. But now we're just going to use the image labeling custom, though, this time. We're going to load the model. And to load the model, we're just going to get it from our asset folder. Finally, configuring the image labeler options. So there are a couple of options that we can see over here. The first one is to set a confidence threshold. So if the machine learning model, for instance, it's less than 50% sure that this is indeed what you're seeing, they shouldn't come back to us, so we won't have to deal with all the noise. And we can also set like a max result count. And this is how many results will come back to us. If we set it to the default, if we leave it to the default, it's going to be 10 results for each image that it sees. Finally, we just need, again, a labeler. that it will take our model with our options and will create the image labeling object. The same as before, we are going to prepare our input image. And this time, we're going to get it from the gallery. So we're going to create it through a URI. The input image, again, is the object that we want to use. But this time, it's going to be from a file path. And we're going to run the image labeler. And again, it's the same thing. We just call the process. We feed it with our image. And then we have the two listeners. Inside those listeners, we will get the labels, depending on the options that we already gave. For this one, we gave 5 options, if you remember. So it will only show us 5 options, or less if they don't have that threshold. And then for those labels, we get a text. This is basically like what that label is, a chair or whatever. Then we have a confidence level. And finally, we have the index. The index is like it has all of the data in there, and it will give you like the index of that. It doesn't have to do with the confidence, though, or anything like this. So it's just for internal use, I guess. I don't know. This is a picture that I took yesterday. And for this image, I did run the labeler. So this is what it came back to us. I don't know if this is correct. It should be correct, right? It's the art pavilion? OK, cool. Questions, and before you get started, one of the questions that I think that everyone will have is, because we saw that it goes for, as we saw, like every single continent has its very own model. So what happens, like if I post over here, the Statue of Liberty, for instance, will it understand it? Well, yes and no. It does get that it's the Statue of Liberty, but the first results that will come back to you are the one that it's in Paris, and not actually the one that it's in New York. If you do have the other model, the first one that it will show, it's going to be the one in New York and not the one in Paris. So it really depends on, like, it will recognize what it sees, but they are fine-tuned just for that continent. What you can do is that you can download those type of models, and of course, it gets even more significant when it comes to natural language understanding or natural processing in general, like language processing in general. And then depending on like the location of the user, then you can download the appropriate model that you want. And this is why also the unbundled version is the best version that you can have, because then you can check if the location changes, then you can download a new model instead of running an outdated model.
Okay, so I was using Camera X with TensorFlow Lite custom model and the image proxy that we get from the Camera X. Do you have a nice method to transfer it to bitmap?
To transfer it to bitmap? Why would you transfer it to bitmap?
Because the TensorFlow Lite model just uses the bitmap.
But so...
No, I didn't use this. I used importing the TensorFlow directly from Android Studio. So it creates you the XML, and it creates you a wrapper code to use the model. It just creates all the classes, and you just use it.
So you didn't use the ML kit, you just use TensorFlow.
Yep.
I don't know, to be honest. This has to do just with Camera X.
Yeah, I mean, Google has in its code lab the methods for converting the image proxy to a bitmap, but they are all deprecated, so I just wondering if you...
I don't know. I haven't done much like on this side. I have used Camera X, but just for like showing the images or doing some stuff with images. You definitely will need to save those information because Camera X comes a lot with metadata. And those metadata are definitely not going to be in that bitmap, or at least not all of them. So you do definitely need to keep track of all the metadata that come from the image proxy and then move forward, because I don't see that working otherwise, to be honest.
Yeah, I mean, they brought a class, helper class, to transform it, but it's all, every method is deprecated in it. So I was just wondering if you maybe know how.
No.
Because a lot of these custom models, they use bitmaps and not this image proxy.
Yeah, they like one of the, like I can go back.
Yeah, the file one that you showed.
Yes, yeah. So you can see that using a bitmap is actually supported. It's going to be exactly the same thing. So for everything, you still need to use that input image class. And then the input image dot from bitmap, it's just going to take care of all the rest. If the metadata is correct, then it will work. If it's not correct, if the rotation, for instance, is missing, they will show you an error, and you will have to handle this and do everything by yourself before creating, before feeding this.
No, I tried the methods they provided. They work, but they are deprecated, so I don't know when they will be, dropped.
Yeah.
So it's a very specific question.
Yeah.
Do we have some lighter questions?
Yeah, I have one more light question. Let's
Please.
say for the problem of the landmarks, can we just download all the models and then just switch them by the location? Would that work?
Yeah, you can, but they're going to be like taking a lot of space for your user. So you should be checking the location and then maybe regularly update them. But if you just download for all of the continents, all of the landmarks, then yeah, it's going to be one massive APK.
Okay, thanks.
Do you have some more questions? We are here to answer. Yeah, here in the third row. Yeah, here. Just shoot the ball. Basketball, yeah.
Hi, one question. So you mentioned a lot of those kits are processed on the device. So I'm interested. How does some low-budget phones do with it? How are the performance in the apps? So is this a problem? I'm not an Android developer, so maybe this does not make sense. But for some low-end Android phones, are we going to have some big performance issues in our apps or something like that?
So if it's using live caption, either this is video or camera, there can be some serious delays. There are a lot of things that you can do to improve the performance. One of them is to just drop the frames. If they're coming, like you're just throttling everything, you drop every frame that you don't need anymore because the next one is coming. And show like the updated data to your user. If it's not live capture, then you shouldn't have any issues.
Okay, thank you. And maybe just one more. If you have some interesting projects that you worked in that are now in production, what did you do and what were the main problems or things like that?
So it's not yet on production. It's what we're currently working, or I'm working in my agency. It's also what fired this talk, because I started working on that. We knew that we wanted machine learning. We didn't know exactly, like, you will Google machine learning on Android, and AutoML comes back to you, Cloud Machine Learning comes back to you, TensorFlow comes back to you, MLKit comes back to you, and a bunch of other things from all the rest of the companies as well. And it's very difficult to know the differences between all these and know what actually works for your case, because you don't want to start with a TensorFlow if you can actually use a pre-trained model. Kind of makes sense, right? But in order for you to understand, you have to go through all of those links and find out what you actually need. So that was one of our challenges. The other challenge was that it was basically a hardware detection. So we had to get input from the audio and then feed that to a model. If it would understand the hot word, then it should do something. Otherwise, it should just keep listening till it actually hears the hot word. The problem with that is that we had already a TensorFlow model, because that used to work on Android things. When they killed Android things, we had to migrate to Android. And we didn't want to start training again the model, because the model was working really good on the Android things side, so we just wanted to keep that model. But the migration from the TensorFlow to the TensorFlow Lite, sometimes it's not that easy, because you have a lot of metadata and a lot of headers, and not all of the algorithms that are actually supported in the TensorFlow Lite that TensorFlow, like the normal one, supports. So another challenge was that. And after the conversion was successful, finally, Android Studio, the Android app would crash every time that we would feed the model some data. And we needed a machine learning expert who was also an expert on Android in order for us to tell us what is wrong, because the machine, the app was crashing without a very helpful message. So for us, it was very difficult to find out what it was. The problem was with the input data. We were feeding it bytes. It was expecting strings. So it's stuff like this. When you go,
nice.
When you go into, let me have like this. When you go on that side, it's not fun.
Okay, you got your answer, I guess. Anybody else? Here, the gentleman in the 5th row.
Hi. Okay, so I was wondering if you go to the left side and you don't have a predefined model, do you feel like you can do any significant work if you don't have strong knowledge in math?
You acquire some. If you don't have any, you acquire. Otherwise, it's not going to work, no.
Mm-hmm.
When you go on that side, it's the dark side of the moon. It's all you. You're all alone. If you're an Android developer, good luck. If you're a machine learning developer, well, still good luck, but at least you know what you're doing. You need a lot of expertise on that. So if you don't have the knowledge, you acquire it. It takes a lot of time. It takes a lot of effort. Definitely a lot of time, not just for you to find out how it works and what you need, but also for the training. So depending on your infrastructure and your data set and all of this, also a great challenge is to actually find the data set and gather everything that you want. For us, it was recordings. So we had thousands of people recording thousands of words, and those have to be stored and be prepared and everything. So it was also a great challenge that we had. But yeah,
don't go to this side, but what if we go to this side?
If you go there, just make sure you actually have someone in machine learning, like an expert there, that can help you along with the way, because you're getting stuck a lot of times.
Okay, thank you.
We like your energy. Do it. Let's try.
I have a question. So first, thanks for the talk. Yeah, I'm here.
Okay.
So I used ML Kit a few years ago for OCR, and it is fun, and it seems to me like a gimmick. You need a lot of additional work to make it feasible in the production. So what are your thoughts on that? Do you have any real-world examples or any real-world use cases which could use the ML Kit out of the box?
Barcode scanning would be the easiest one. Barcode scanning works like this. It's 15 lines of code. You don't have to deal with anything else. You just do it. Then like text recognition, if you want a person to just take photo of a text and then get the handwritten text into your application, then this also works out of the box. Basically, all the first APIs that we saw work out of the box without any, like, a lot of work from your side. As we saw, it's just a few steps, and for the rest, it also works the same.
I was more thinking like we were trying to scan the document of a person, and too much of the data was wrong. So we could filter it out, we could go in that direction. It will take us a lot of time, but we would do it. And in the end, we went with the already done solutions, paid solutions, for example, Microblink or Regula for scanning the documents. So that's why I'm asking. It seems to me that we need to do a lot of work to make it really, really useful tool.
Okay, well, first of all, it really depends on, like, the photo that, like, how the user is gonna use it. Second of all, and that goes with any machine learning model, the more data that you're feeding to it directly, the less accurate it will be. Like trying, for instance, translating on Google Translate 5 sentences and try translating 50. On 5, it still makes sense. On 50, everything's gone. There is no context whatsoever. The same goes with an image. Like if it's a full paper of handwriting, then it may not recognize it as well as like the paid solutions that you said. If you already know, like if it's a form, that it's a form from your company, then you can take that form and just train the model with that form. So you get a lot of those forms already filled in, and then you just basically use the supervised machine learning and say, like, this is correct, this is not correct. You can do that. But yeah, like real life scenarios, yes, there are. Do they always work? It depends.
Thanks.
Some more questions? You warmed up already? No more? 5, 4, 3, 2, 1. We're done. One big applause for
right.
Eliza.
Thank you very much.